Hey students, today we're going to look at differentiation, rate of change. All right. So rate of change simply links together three different quantities and puts them to a single equation. That's why we call it connected rates of change. All right. So looking at this question, we have water being poured into a container at a rate of 6 cm³ per second. Now the units tell a lot and give away a lot of important information. So if you look at the units, it is cubic centimeters per second. So this is a hint to us that this 6 cm³ per second is actually our dV over dt. All right, our rate of change of volume with respect to time. Volume because it's given in cubic centimeters, time because it is given per second. So that's one, we have our rate of change of volume with respect to time. Next, we are also given the volume function of the equation over here. What we can do is that we can actually differentiate this volume function with respect to h, and that will give us dV over dH. Okay, so let's do that very quickly. Now, it would be useful if we can expand the brackets first to obtain 3 over 2 h squared plus 8h times 3 over 2, which will give us a value of 12h. Alright, and from here we can simply do our term by term differentiation. So dV over dH will give us 3h, let me write that again, the bottom, plus 12. So this is simply our rate of change of volume with respect to the depth of the water in centimeters. Now we have one last missing piece of the puzzle. The question says, find the rate of change of the depth of the water. So depth of the water is given to us in centimeters. And rate of change refers to the time. So the question simply wants us to find what is dH over dt, given the other information in the question. Okay, so let's go through that again. We have our dV over dt here, rate of change of volume with respect to time, which is 6 cm³ per second. We have differentiated our volume function, and that gave us our dV over dH. And our question requirement is to find our dH over dt, the rate of change of depth of water. So now we can find a way to relate the three of them. Now, there are two ways we can link them together. The first method is to write it as dV over dH equals to dV over dt multiplied by dt over dH. The other way to see it would be using dV over dt equals dV over dH multiplied by dH over dt. Now, essentially, they are the same formula, but students tend to find the second variation of the formula, which is this, more convenient to use. The reason is because all the values are actually non-inverted. Over here, the first formula, notice that this is actually inverted. So we have to flip our values over if we want to find our answer later. However, for the second method, we can simply just plug in the values without having to worry about that. So what we have over here is 3h plus 12. There's our dV over dH that we found just now. Equals to, oops, this one shouldn't be this. This one should be our 6 cm³ per second, yes. dV over dH will be 3h plus 12. And last but not least, we are called to find our dH over dt. However, we still have one final piece of the puzzle which is missing. And that is, we don't have a h value that we can plug in to find the solution. There's one last information in the question that is very useful, which is given here. When the volume of the water is 72 cm³. Now, we can sub this into our original volume function. So we have 72 equals to 3 over 2 h squared plus 12h. plus 12h. And using this, we are able to solve it as a quadratic function to obtain possible values for h. So we will have 3/2h² plus 12h minus 72 equals to 0. There are many ways we can do this. We can either use completing the square method, or we can simply use our quadratic formula to solve this. So I will use the quadratic formula method. We have h equals to minus b plus minus square root b squared minus 4ac over 2a. All right. So if we click on our calculator and we press the quadratic solver, we can obtain the answer in no time. So our a value is given to us by 3/2. Our b value is 12. And our constant term is negative 72. And this will give us the h values of 4 or negative 12. And as you all know that we are unable to use the value negative 12 because that has to be positive. So we'll reject this particular value and you'll focus on using the depth as 4 cm instead. So when the depth is 4 cm, we are able to plug this particular value into our rate of change formula right down here. Okay, and subsequently this will give us 6 equals to 3 times 4 plus 12 multiplied by dh over dt. So if we do the math, here we will have 6 divided by 24. And our rate of change of the depth of the water will be given to us by 1/4 or 0.25 cm per second. So let's run through the sequence again before we end off. First and foremost in the question, look for the 3 different differentiation functions. Most of the time, the question will want you to find one of them, and one of them will be given as a function which you have to differentiate. In this case, it's dv over dh that we have to differentiate to obtain one of the values. Keep a lookout also for given values in the question, and look at the units. The units are very useful in determining whether or not it is dv over dt or dh over dt. All right. Once done, we can write out the rate of change formula. Of course, I would encourage you to use the second variation of the formula. If you find the first one useful, you can also use it as well. Anyway, both will work. And after that, we will sub in usually the constant term or one of the values to obtain what we are trying to find in the question. And that will be the conclusion of the rate of change formula. So hopefully this video has been helpful to you, especially if you're struggling with related rate of change questions. And yeah, do tune in for future videos. And again, these are our products and also our social media links. Feel free to follow us for more interesting questions, as well as more guidebooks and videos. Have a good week ahead.